Okay, Assalamualaikum. Today we continue with comparing several multivariate population mean, which is the one-way ANOVA. In your textbook, you can refer page 296. Okay, from the previous lesson, actually you have learned how to comparing the several multivariate ataupun comparing the mean multivariate for two population. Betul? You can use the test and also the confidence interval. Okay, so today we proceed with the comparing several multivariate population mean, which is when your population is more than 2, you will use the one-way MANOVA. Sebab kita deal dengan multivariate. Okay, so actually untuk one-way MANOVA, okay, one-way MANOVA here. Okay, actually ianya adalah one-way MANOVA, but before that kita flashback dulu about the univariate ANOVA, which is that you have learned before this in step method subject, I think. Univariate ANOVA, we will use the concept of univariate ANOVA to apply when we are using the one-way MANOVA. Okay, so because of that, I nak you flashback dulu sedikit about the univariate ANOVA, that you know. You already know we are using the univariate ANOVA when you want to compare the mean for several population. Betul tak? Okay, so sama juga dengan one way MANOVA. Cuma because of kita punya variable is we deal with the variable, several variable. So because of that, kita kena gunakan one way MANOVA. But untuk univariate ANOVA, you deal dengan hanya satu variable, but for several population, more than 2 population. Okay, so actually sebelum kita proceed, sebenarnya when we want to use the one-way MANOVA, sebenarnya we want to compare more than 2 population. Okay, more than 2 population need to compare. Alright, so you will have the population for matrix of x11 until matrix of x1 and 1. Okay, so from the one-way ANOVA, we can see whether the population mean vector are same or not. Okay, so we are using the testing of one-way ANOVA. So you akan ada hypothesis testing, you akan ada test statistic, you akan ada decision rule. Okay, so kalau reject hash not, kita boleh katakan there are significant difference of all the variable among the populations. Okay, so first of all, sebenarnya you need to know about the assumption to conduct the one-way MANOVA. You can refer page 296. Okay, so kita ada notation of capital X L1 sehingga capital X L and L. Okay, L tu adalah refer kepada and L adalah refer kepada sample size of population, dan we have the mean for every population. Notationnya adalah mu L. And then the second assumption adalah the all population ni sepatutnya ada common covariance matrix big sigma. Okay, ada common covariance matrix means that the covariance matrix for first population should be equal with second population, should be equal with the third population. So kita noted as big sigma saja. And then each population should be multivariate normal. Okay, but when the sample size are large, so the third assumption tadi kita boleh ignore je lah, sebab when sample size is large, we can assume ataupun we can use the central limit theorem. We can assume that every population are multivariate normal. Okay, so kita proceed dengan flashback sikit ataupun revision about the univariate ANOVA. Okay, so we talk about the univariate ANOVA. So because of that, all the X here not in bold notation. Okay, sebab univariate, kita hanya ada satu variable sahaja. Okay. Okay, so kalau you tengok ANOVA table ni, okay, pernah nampak kan ANOVA table ni sebelum ni? Okay, you will have the source of variation. Okay, kalau tak nampak sangat, you can refer your textbook. Sorry. You can refer your textbook. Actually ada dekat page 300. Okay, so you will have the source of variation, ada treatment dan juga residual. Treatment tu adalah refer kepada your population, betul tak? Okay, and then you akan ada sum of square. Sum of square treatment, it will be summation of NL multiply mean of L, which is the population ataupun sample mean, minus dengan X bar, mean untuk overall, then square SS residual, double summation of observation minus dengan mean of population, mean of each sample population, sample for each population, square, and then SS corrected is which is the summation of SS treatment plus SS residual. Okay, look at the degree of freedom. Degree of freedom when we are using the one-way MANOVA nanti, degree of freedom dia sama. Okay, so degree of freedom for treatment will be G minus 1. G here adalah number of population. Okay, berapa banyak population you ada, so minus 1. Okay, and then degree of freedom for residual is total of sample size minus dengan how many population involved, and then degree of freedom for total, SS total adalah summation of these two degree of freedom ataupun summation of NL minus 1, total of the sample size minus 1. Okay, that is the ANOVA table. So kita tengok flashback macam mana kita punya hypothesis testing, how to conduct the one-way ANOVA. Okay, so the hypothesis will be mu1 equal to mu2 until mu g. Okay, it depends how many population involved. Kalau you ada 3 population je sehingga m3 saja, mu3 saja. Okay, hash note will be at least one pair of mean are not equal. Okay, ataupun kalau you nak buat hypothesis tu dalam bentuk sentence pun boleh. Hash note will be there are no significant difference of the variable, ada satu variable saja kan, of the variable among the berapa population you, among the 3 population or 4 population, okay, ataupun the treatment. Ataupun another term that you can use is using the notation of tau. Okay, hash note will be tau 1, tau 2 until tau G, okay, equal to 0, which is no treatment effect. Okay, if the mean for all population is equal, so we can say that there is no treatment effect. Okay. Okay, and then the F statistic will be this one, which is SS treatment divide its degree of freedom over SS residual divide its degree of freedom. If this test statistic is more than the F distribution, which is kita comparekan F statistic with the F distribution with degree of freedom of residual, SS treatment dan SS residual. If this test statistic F is more than F distribution that you have from that you find from the F table, so we reject hash not. Bila reject hash not, what can you conclude? Okay, when hash not is rejected, we can say that there are significant difference of the variable among the G population. Alright, so you nak tahu which variable yang which population yang differ, kita boleh buat tadi tu sebelum ni lah, boleh buat Banforoni simultaneous interval, confidence interval. Okay, itu untuk one way ANOVA. Okay, contohnya example ni in your textbook, example 6.8, page 301. Okay, so given here the population actually data dia from the example 6.7. Okay, given the population 1, population 2 and population 3, we have 3 population. So because of that, kita gunakan one way ANOVA because we have more than 2 population. Okay, so untuk population 1, we have the data is 969. Population 2, we have 2 observation. Population 3, we have 3 observation. So the variable involved here only one variable. Okay, so first of all, you need to find the mean for each population, right? Mean for each population, and then mean for overall. Why? Because of we need to use the X bar to find the SS treatment using this formula. So which is N1 X1 X bar 1 minus X bar. So it will be 3 adalah 3 here is the sample size for first population. Okay, 8 adalah here mean for first population minus dengan overall mean. Okay, you need to do for each of the population, you will get 78 here. Okay, and then to find the residual, this is the formula. Okay, apply the formula for each of the observation. So kena buat untuk setiap observation. So 9 minus 8, because of 8 adalah mean for first population. So sehingga sini 9 minus 8, and then 0 will be minus 1 because of 1 adalah mean untuk second population. So you need to do this for each of the observation, and then you will get 10. So the degree of freedom will be here G minus 1. So 3 adalah G, which is the number of population involved, 3. Okay, degree of freedom for residual will be summation of n. So you total up all the sample size minus dengan how many population involved. So you akan dapat 5. So apply the formula to find the F statistic. You will get this 19.5 and compare with the critical value from F distribution. You will get 13.27. So from here we can see that F statistic more than the value of 13.27. So kita reject hash not. So kita akan reject this hypothesis testing, ataupun you boleh gunakan value mu pun boleh. So what we can conclude from here, there is no treatment effect, ataupun you can say that there is no significant difference of the variable among 3 population ataupun 3 treatment. Okay, itu adalah that is the revision how to conduct the one-way ANOVA when one variable only involved. Okay, how about when we are dealing with multivariate? Okay, multivariable, and we want to compare the mean vector sebab ada beberapa variable kan. We want to compare the population of mean vector for several population. Kita ada beberapa variable dan beberapa population that we need to compare. So kita gunakan one-way MANOVA, which is the multivariate analysis of variance. Okay, so if you can see here, all this will be both sebab kita deal dengan multivariate or vectors. Okay, all of this assumption that you have learned before this. Okay, tau here represent the L treatment. Okay, ataupun population lah, the treatment. Alright. Okay, we go to the hypothesis testing. Tadi I dah ceritakan dia punya assumption of the multivariate one-way MANOVA. Tadi kita ada 3 assumption kan, which is the sample size, page 296 tadi kan, 3 assumption that I have told you. The first one, the random vector both of XL1, XL2 until XL and L adalah from the sample size of NL with population mean mu L. Okay, for every of the population. Yang kedua, all the population have the common covariance big sigma, and each the population must be multivariate normal. Okay, so the hypothesis testing sama macam univariate ANOVA, but it should be bold. Sepatutnya kat sini should be bold. The mu1 bold equal to mu2 bold equal to mu-g bold equal to 0, or at least one treatment mean vector are not equal. Sebelum ni at least one mean not equal kan, right? So sekarang ni kita kena sebut at least one treatment mean vector are not equal. Sebab kenapa vector? Sebab we deal with several variable. Ataupun you also can use the notation of tau, or you can write like this, macam dekat mu tadi pun boleh, at least one of the mu L not equal to 0. Okay, so MANOVA table in your textbook you can refer in page 302. Kalau kat sini tak nampak sangat kan. Okay, page 302. Okay, so dia punya karakteristik sama. Source of variation we have treatment and residual dan juga total, and then you need to calculate the sum of square and the cross product. Kat sini we noted as B and W. Okay, B adalah because of we deal dengan matrix. So B and W ni will be the matrices. Okay. Which is summation of NL X bar L, main vector for each population, minus dengan X bar. X bar tu adalah mean for overall. Multiply dengan X bar L minus X bar transpose. Itu untuk B. Okay, untuk W, sama ada you use this formula ataupun you will have another formula. Sekejap lagi I tunjuk. Okay, degree of freedom. If you can see, the degree of freedom is equal like ANOVA table. One way ANOVA table. Okay, let's proceed. Okay, ini yang I cakap tadi. The other formula untuk dapatkan matrix of W, which is the sample size for each of the population minus 1 multiply dengan sample variance covariance for each population. Sample variance covariance for each population. Okay, so you need to hafal the formula. Okay, so this notation dinamakan weak lambda, which is the determinant of matrix W. So W nanti you akan dapat dalam bentuk matrix. So you cari the determinant and then divide dengan determinant of B plus W here. Matrix here. Okay. You cari determinant of matrix B plus W. So macam mana kita nak buat decision rule? Where is it? Okay, tak ada kat sini. Okay, betul sini. Okay, macam mana nak buat decision rule? Okay, decision rule ada beberapa. It depends on how many variable involved and how many groups ataupun how many population involved. We have 4 decision rule here. Semuanya gunakan F, sampling distribution of F. If P equal to 1, G more than 2, we will use this formula yang sebelum ni sebenarnya. So kita akan gunakan yang here lah. So sama ada 2, 3 atau 4. So actually you kena pilih lah yang mana yang sesuai dengan you punya information ataupun data. How many variable involved and how many population involved. The notation here ni adalah big lambda tadi, ini adalah weak lambda. Notation untuk weak lambda, how to find the weak lambda? Using this formula tadi. You will use the weak lambda untuk nak buat decision rule. So, we will reject hash note if this statistic more than the value of F distribution with the degree of freedom here. Okay. So kita reject hash note bila this statistic more than this statistic more than this statistic more than this. It depends pada how many variable involved and how many group ataupun population involved. Okay, let's see the example 6.9 from your textbook 304. Okay, so suppose an additional variable is observed along with the variable introduced in example 6.8. Sebelum ni example 6.8 only involve one variable, so kita using the univariate ANOVA. Okay, so now we have the additional variable x2. The sample size for the first population is 3, second population is 2, and third population is 3. Okay, So kalau you tengok kat sini, dalam table ni we have 2 variable, and then we have 3 groups. 3 groups maksudnya we have 3 treatment or we have 3 population. So we can transfer ke dalam bentuk matrices. Okay, so this 9 3 kan vector of x. Here 9 first observation, 3 first observation for second variable, 9 first observation for first variable. Okay, 6 first observation from second juga for second observation for the first variable. 2 is second observation for second variable. 9 is third observation for the first variable, third observation for the second variable. So these 3 observation adalah from first population. Okay, same goes with the second population and third population. Okay, you need to know how to transfer ke dalam bentuk matrices because of we deal dengan matrices when we want to find the B and W. Okay, so after that we need the value of mean vector for each population and overall mean vector here. How you get 8 here? 8 ni means that the mean for first variable in first population. How you get 8? 9 plus 6 plus 9 divided by 3, you will get 8. How you get 4? 3 plus 2 plus 7, you will get 4. Okay, mean vector x2 bar here will be the mean vector for second population. How you get 1? 0 plus 2 divide 2. How you get 2? 4 plus 0 divide 2. x3 is the mean vector for the third population. How you get 2? 3 plus 1 plus 2 divide 3. How you get 8? 8 plus 9 plus 7 divide by 3. Okay. And then we need also the overall of x bar. Okay, so how you get 4? You tambah semua sekali lah. 9, this one, 4 ni adalah mean vector, adalah mean for first variable, which is you find the mean for this column, first variable for overall. 5, you get the mean for the x2 column, you akan dapat 5. And then we also need the variance covariance matrix for each of the population, S1, S2 and S3. Okay, how you get 3, how you get 7, how you get 3, how you get 7, just find the 3 ni maksudnya adalah the variance for the first population, the variance for first variable. Okay, the variance for the first variable in first population. Faham tak? 7 adalah the variance, 7 here adalah the variance for the second population in first. 7 adalah variance for the second variable in first population. Okay, 3 here adalah the covariance. Okay, so you just gunakan value x1 dan x2 in first population saja untuk cari variance for x1 dan variance for x2. Here 2 pula adalah variance for first variable in second population. Gunakan value kat population yang kedua sahaja untuk dapatkan variance and covariance. Same goes with S3. Okay, so now we have the matrix, the mean vector dan juga covariance matrix for each of the population. Okay, so we conduct the one-way MANOVA. First of all, you should have the hypothesis testing. Semua kat sini should be bold. Okay. At least hash not sorry, kat sini hash 1 hash 1, at least one treatment means vector are differ. At least one treatment mean vector are differ. Hash 1. Okay, how to get the b, value of b? Okay, from the formula, it is summation of nl x bar l minus x bar. So yang pertama, okay, I explain here. First population tadi, we have the sample size is 3, right? First population, the sample size is 3, so NL will be 3 for the first one here. And then XL bar minus X bar, 8 minus 4, which is here 8 minus 4. Okay, 8 minus 4. Yang kedua kat sini, 4 minus 5. 4 minus 5. Okay, you akan dapat difference of the mean vector. Okay, multiply dengan benda yang sama, vector yang sama, cuma transposekan dia. Sama juga dekat sini, n for second population is 2. Okay, is 2. And then how you get 1 minus 4? Because of 1 here minus 4 here. Okay, so you buat sehingga the third population, and then multiply, and then plus all of that, you akan dapat this matrix, iaitu matrix B. Okay, and then use the formula that I mentioned before this to find the matrix of W. Just apply. Tadi dah ada variance covariance matrix for each of the population, so just use that to find the matrix of W. And then we also need the matrix of B plus W to find the weak lambda. Okay, we have all of this W. Find the weak lambda. Notation here adalah big lambda here, big lambda star. Okay, which is the nak cari determinant of the matrix W. How to find the determinant of this matrix? Will be 10 minus 24 cross, kan? Macam ni dah belajar sebelum ni. Cross 10 minus 24. Sorry, 10 multiply 24 minus 1 multiply 1. Okay, and then sama juga find the determinant untuk matrix B plus W. So you will get 0.0385. Okay, so we want to use which distribution to compare and which statistic. It depends pada how many variable involved and how many population involved. In this example, number of variable is 2, x1, x2, and the population we have 3 population tadi. So we use this formula, right? Use this formula P2G3. P2G3. So we will use this formula. Okay, apply the formula because we have all of this. Lambda tadi dah ada, you dah tahu summation of n, total of all the sample size, so you get 8.19, and compare with the distribution of F here, you akan dapat 7.01. Okay, because of test statistic 8.19 more than critical value 7.01, so we reject hash not. The conclusion can be made is the treatment effect are differ, ataupun macam mana you nak explain another way how you can conclude adalah there are significant difference of all variables among the 3 population. Kita ada 3 population tadi, kan? So there are significant difference of all variable, ataupun kalau you tahu the name of each variable. So you say x1 and x2 among the 3 population ataupun 3 treatment. If you know about the population, sama ada faculty ke apa ke, you can mention that. Okay, that is the way how you conduct the one-way MANOVA in order to compare the multivariate mean of several population. Okay. So, if a large sample size is involved, we also can use this method tadi. Maksudnya nak gunakan sampling distribution yang tadi itulah. Ataupun another way, we can use this formula if summation of n is large. We can use this formula and modification from the Bartlett sebenarnya. Okay, which is the kita compare kan dengan chi-square distribution. Before this, kita compare dengan F. So, ada dua cara lah kalau large sample size. Sama ada you gunakan the previous method tadi ataupun gunakan this method untuk dapatkan F statistik. P adalah number of variable, G adalah number of population, ln kan weak lambda. Then comparekan dengan chi-square distribution with degree of freedom. Kat sini salah sikit P multiply G minus 1. Yang ni betul. Degree of freedom ni adalah P multiply G minus 1. So, if the test statistic is more than the critical value from chi-square distribution, so we reject hash not. Cara nak conclude sama macam sebelum ni. Okay. So, this is another example sebenarnya. So, kalau kita tengok kat sini, example 6.10 in page 306. Nursing homes can be classified on the basis of ownership, private party, non-profit organisation and government. We have 3 treatment here, which is 3 population. And certification, skilled nursing facility, intermediate care facility, or a combination of the two. One purpose of a recent study was to investigate the effect of ownership or certification or both on costs. 4 costs were considered, which are the cost of nursing labour, dietary labour, plant operation and maintenance labour, dan juga housekeeping and laundry labour. A total of 516 observation on each of the 4 cost variable were initially separated according to the ownership. So, kat sini, from this case study, we know that we have the 3 population, which is the ownership, ataupun treatment. And we have 4 variable that we need to analyze, which is labor of cost of nursing, dietary, plant operation, dan juga housekeeping and laundry labor. Alright. So, in your textbook, page 306 and 307, ada kat sini is given the descriptive of each of the mean dan juga mean vector and also the covariance matrix for each of the population. So, kita ada 3 population, private, non-profit and government. Okay, so kat sini, this part adalah mean vector for first population. So, 2.066 ni adalah mean for first variable in first population and so on. Okay, kita ada 4 ni, maksudnya ada 4 mean, ada 4 variable tadi. Okay, and also the covariance matrix is given. The main diagonal will be the variance for each of the variable for the corresponding population ataupun treatment. Okay, so we can apply the method one-way MANOVA tadi. Kita cari W, cari B untuk dapatkan weak lambda. Okay, cuma kat sini sebab because of we don't have the data, we don't have the overall data. Untuk cari x bar, we have another formula that you need to know. This the formula untuk dapatkan overall x bar, we use the mean vector for each of the population. Okay, so dah boleh cari W because we have the covariance matrix for each population. We can find B. Okay, sebab you already have each of the apply this formula dalam bentuk matrix. Last sekali you will get this matrix. Okay, try buat nanti. And then you have all the value, all the matrix, so you can find the determinant of W and B plus W to find the weak lambda. Okay, and then di sini digunakan this test statistic. Kenapa? If we can see here, our P is 4, our our population is 3. Okay, tengok balik table 6.3 you tadi dekat page 303. So when P is 4, which is more than 1, and your G is 3, so we will use the test statistic, the last one. Okay, test statistic here. Okay, try to calculate, bertetap the test statistic will be 17.67. Okay, so we comparekan dengan F. Kalau dalam you punya table 6.3 tadi, kita comparekan dengan F, this one, F 2P multiply 2 summation of NL minus P minus 2. You akan dapat 510. Okay, the value is 2.51. So the value of F ni sebenarnya, kenapa dia buat macam ni, sama, boleh juga F ni kita tukar ke dalam bentuk chi-square. We can use the chi-square value. It is equal ataupun parallel with the F distribution. Kena bahagi dengan 2P. Okay, bahagikan dengan 2P. So, dapat 2.51. So, sama ada digunakan F macam biasa pun tak ada masalah. So, since the test statistic more than the critical value, so we reject. H0, conclusionnya, average cost differ depending on the type of the ownership, or we can conclude that there are significant difference of all the variable, which is the cost, among the three type of ownership. Okay, itu kalau kita gunakan one way MANOVA method tadi, gunakan distribution tadi lah, sample distribution tadi. Tapi we also can use this distribution test statistic because of n is large tadi, kan? Because of n is large, and dia berapa tadi? 200. Okay, and dia tadi 516, kan? 516 we consider as normal, as large. So we also can use this alternative to calculate ataupun to make the decision about the hypothesis. Okay, comparekan this test statistic dengan chi-square P G minus 1. So you akan dapat the same result. The result will be consistent, and then you can make the conclusion as before this. Okay, so this is the popular MANOVA statistic used in the SPSS. So nanti jangan terkejut bila you nak dapatkan value MANOVA, dia akan keluar semua ni, weak lambda, when you lowly, pili, dan juga Roy largest. Okay, but we usually use the weak lambda value, dan juga dia punya significant value tu kita gunakan yang weak lambda sahaja. So actually, walaupun you have all this statistic, the conclusion is still the same. Cumanya maybe kalau kita nak buat manually, Hotelling trace ni, Pillai dan juga Roy ni, maybe kita kena compare dengan the other distribution lah. Kalau with lambda kita compare dengan F distribution tadi, ataupun kalau sample size large tadi kita compare dengan chi-square kan. Okay, so in our syllabus kita just cover untuk weak lambda saja, tapi if you run the output from the SPSS, dia akan keluar all this statistic. Okay.